Thank you. Now, unlike Dojo, obviously that was not real. So Dojo is real. The Tesla bot will be real. But basically, if you think about what we're doing right now with the cars, Tesla is arguably the world's biggest robotics company because our cars are like semi-sentient robots on wheels. And with the full self-driving computer, essentially the inference engine on the car, which will keep evolving, obviously, and Dojo and all the neural nets recognizing the world, understanding how to navigate through the world, it makes sense to put that onto a humanoid form. They're also quite good at sensors and batteries and actuators. We think we'll probably have a prototype sometime next year that basically looks like this. And it's intended to be friendly, of course, and navigate through a world built for humans and eliminate dangerous, repetitive, and boring tasks. We're setting it such that it is at a mechanical level, at a physical level, you can run away from it and most likely overpower it. Hopefully that doesn't ever happen, but you never know. So it'll be a light 5 miles an hour. You can run faster than that, you'll be fine. It's around 5'8", has a screen where the head is for useful information, but it's otherwise basically got the autopilot system in it, so it's got cameras. Got 8 cameras and full self-driving computer, and making use of all of the same tools that we use in the car. Things I think that are really hard about having a useful humanoid robot is can it navigate through the world without being explicitly trained, without explicit line-by-line instructions? Can you talk to it and say, please pick up that bolt and attach it to a car with that wrench, and it should be able to do that. It should be able to, please go to the store and get me the following groceries, that kind of thing. So, yeah, I think we can do that. And yeah, this I think will be quite profound because if you say, what is the economy? It is, at the foundation, it is labor. So what happens when there is no shortage of labor? This is why I think long term that there will need to be universal basic income. Yeah, but not right now because this robot doesn't work. So we just need a minute. Yeah, but I think essentially in the future, physical work will be a choice. If you want to do it, you can, but you won't need to do it. And yeah, I think obviously has profound implications for the economy because given that the economy at its foundational level is labor, capital equipment is just distilled labor, then is there any actual limit to the economy? Maybe not. It is fundamentally extremely expensive to create the system. Somehow that has to be paid for. I'm not sure how to pay for it if it's fully open sourced. Yeah, unless people want to work for free. But I should say that this is, if other car companies want to license it and use it in their cars, that would be cool. This is not intended to be just limited to Tesla cars. We should have Dojo operational next year, and I think we'll obviously use it for video training. Primarily this is about, primary application initially is we've got vast amounts of video, and how do we train vast amounts of video as efficiently as possible, and shorten the amount of time. If you're trying to train to a task, like just in general, innovation is how many iterations and what is the average progress between each. And so if you can reduce the time between iterations, the rate of improvement is much better. If it takes like sometimes a couple days for a model to train versus a couple hours, that's a big deal. But the acid test here, and what I've told the Dojo team is it's successful if the software team wants to turn off the GPU cluster. But if they want to keep the GPU cluster on, it's not successful. Driving is fundamentally, basically, almost entirely vision neural nets. Like it's running on a biological vision neural net, and what we're doing here is a silicon camera neural net. So there is some amount of audio you want to hear if there's like emergency vehicles, or I guess converse with the people in the car. Somebody's yelling something at the car needs to understand what that is. Things that are necessary for it to be fully autonomous. We actually do train on using data from probably like 50 different countries, but we have to pick, as we're trying to advance full self-driving, we need to pick one country, and since we're located here, we pick the US. And we get a lot of questions like, why not even Canada? Because the roads are a little different in Canada, different enough. And so when you're trying to solve a hard problem, you want to say, okay, let's not add additional complexity right now. Let's just solve it for the US, and then we'll extrapolate to the rest of the world. But we do use video from all around the world.
Yeah, I think a lot of what we are building is very country agnostic. Fundamentally, all the computer vision components and so on don't care too much about country-specific features. Different countries have roads, and they have curbs, and they have cars, and everything we're building is fairly general for that.
Yeah, and then the prime directive is don't crash.
Right, and that's true for every country.
Yes, just the prime directive. And even right now, the car is pretty good at not crashing. And so just basically, whatever it is, don't hit it. Even if it's a UFO that crash landed on the highway, and still don't hit it. You should not need to recognize it in order to not hit it. So that's very important. And I think we want to aim for the car to be positioned accurately to the sort of centimeter level, something on that order. Sometimes something that I say is taken to too much of an extreme. There are parts of the Tesla system that are almost completely automated, and then there are some parts that are almost completely manual. And if you were to walk through the whole production system, you would see a very wide range from, like I said, fully automatic to almost completely manual. But the vast majority, most of it is already automated. And then with some of the design architecture changes, like going to large aluminum high-pressure die-cast components, we can take the entire rear third of the car and cast it as a single piece. And now we're going to do the front third of the car as a single piece. So the body line drops by 60 to 70% in size. But yeah, the robot is not prompted specifically by manufacturing needs. It's just that we're just obviously making the pieces that are needed for a useful humanoid robot. So I guess we probably should make it. And if we don't, someone else would. So I guess we should make it and make sure it's safe. I should say also volume manufacturing is extremely difficult and underrated, and we've gotten pretty good at that. It's also important for that humanoid robot. Like, how do you make the humanoid robot not be super expensive? And so Tesla has a lot of expertise in power electronics and in cooling. So we took the power electronics expertise from the vehicle powertrain and the sort of advanced cooling that we developed for the power electronics and for the vehicle and applied that to the supercomputer. Because as you point out, getting heat out is extremely important. It's just really heat limited. So it's funny that at the compute level, it's operating at less than a volt, which is very low voltage. There's a lot of amps, so therefore a lot of heat. I2R really bites you on the ass. Dojo's first application will be consuming video data for training that would then be run in the inference engine on the car. And that I think is an important test to see if it actually is good, but is it actually better than GPU cluster or not? But then beyond that, it's basically a generalized neural net training computer. But it's very much optimized to be a neural net. CPUs and GPUs, but they're not designed specifically for training neural nets. We've been able to make GPUs especially very efficient for training neural nets, but that was never their design intent. So GPUs are still essentially running at neural net training in emulation mode. With Dojo, we're saying, okay, let's just ASIC the whole thing. Let's just have this thing it's built for one purpose, and that is neural net training. And just generally, any system that is designed for a specific will be better than one that is designed for a general purpose. I do think that as long as you've got surround video neural nets for understanding what's going on and can convert the surround video into vector space, then you basically have a video game. And if you're in Grand Theft Auto or whatever, you can make the cars drive around and pedestrians walk around without crashing. You don't have to have a neural net for control and planning, but it's probably ultimately better. But I think you can probably in fact, I'm sure you can get to much safer than a human with control and planning, primarily in C++ with perception, vision in neural nets. I discourage use of machine learning because it's really difficult. Unless you have to use machine learning, don't do it. It's usually a red flag when somebody says, we want to use machine learning to solve this task. I'm like, that sounds like bullshit. 99.9% of the time, you do not need it. So, yeah, it's like reach for machine learning when you need to, no. But I've not found it to be a convenient, easy thing to do. It's a super hard thing to do. And that may change if you've got a humanoid robot that can understand normal instructions. But yeah, generally minimize use of machine learning in the factory. The simulator is very helpful when there's these rare cases like collision avoidance right before an accident. And then ironically, the better our cars become at avoiding accidents, the fewer accidents there are, so then our training set is small, so then we have to make them crash in the simulation. So it's okay, minimize potential injury to pedestrians and people in the car. 5 meters, you're traveling at 20 meters per second. What actions would minimize probability of injury? We can run that in sim. I think for the Tesla bot, Optimus, it's basically going to start with just dealing with work that is boring, repetitive, and dangerous. Basically, what is the work that people would least like to do? Overwhelmingly, the data set is the real video from the cars on the actual roads. Nothing's weirder or has more corner cases than reality. It gets really strange out there. But then if we find, say, a few examples of something very odd, and there's some very odd pictures we've seen, then in order to train it effectively, we want to create simulations, say 1,000 simulations that are variants of that quirky thing that we saw, to fill in some important gaps and make the system better. And really, all of this is about, over time, just reducing the probability of a crash or an injury, and it's called the march of nines. Like, how do you get to 99.9999999% safe? And yeah, each 9 is an order of magnitude difficulty increase. We certainly hope this does not feature in a dystopian fi movie, but really, at this point, we're saying maybe this robot can we're trying to be as literal as possible. Can it do boring, dangerous, repetitive jobs that people don't want to do? And once we can have it do that, then maybe it can do other things too, but that's the thing that would be really great to have. It could be your buddy too. I mean, you can buy one and have it be your friend and whatever. I'm sure that people will think of some very creative uses. One of the things we're seeing is that the car's predictive ability is eerily good. It's really getting better than human in terms of predicting, like you said, predict what this road will look like when it's out of sight, like it's around the bend. And it predicts the road with very high accuracy and predict pedestrians or cyclists, wherever behind, where it just sees a little corner of the bicycle and a little bit through the windows of the bus. Its ability to predict things is going to be much better than humans, really way beyond. This is just going to be bot version 1. We'll see. So it needs to be able to do things that people do, and a generalized humanoid robot. You could potentially give it 2 fingers and a thumb or something like that. For now, we'll give it 5 fingers and see if that works out okay. It probably will. It doesn't need to be have an incredible grip strength, but it needs to be able to work with tools, carry a bag, that kind of thing. From the computer standpoint, everything is moving slowly. To a human, things are moving fast. To the computer, they are not moving fast. So I think this is, in reality, somewhat of a false dichotomy. Not that it will never happen, but it will be very rare. If you think of it going the other direction, rendering with full ray tracing, neural net enhanced graphics on something like Cyberpunk or any advanced video game, doing 60 frames a second, perfectly rendered. How long would it take a person to even render 1 frame and without any mistakes? Can't be done. It would take a month just to render one frame out of 60 in a second in a video game. Computers are fast and humans are slow. For example, on the rocket side, you cannot steer the rocket to orbit. We actually hooked up a joystick to see if anyone could steer the rocket to orbit, but you need to react at roughly 6-7 hertz. People can't do it. Not even that's pretty low. We're talking more aiming for 30 hertz type of thing.
Hi, with hardware 3, there's been lots of speculation that with larger nets, it's hitting the limits of what it can provide. How much headroom has the extended compute modes provided, and at what point would hardware 4 be required, if at all?
I'm confident that hardware 3 or the full self-driving computer 1 will be able to achieve full self-driving at a safety level much greater than a human, probably, I don't know, at least 200 or 300% better than a human. Then obviously there will be a future hardware 4 or full self-driving computer 2, which we'll probably introduce with the Cybertruck, so maybe in about a year or so. That'll be about 4 times more capable, roughly. But it's really just going to be can we take it from, say, for argument's sake, 300% safer than a person to 1,000% safer? Just like there are people on the road with varying driving abilities, but we still let people drive. You don't have to be the world's best driver to be on the road. So as we see. Yeah, pull some Wile E. Coyote stuff, paint the tunnel on the wall. We haven't really seen much of that. Sure, right now, if you had a t-shirt with a stop sign on it, which I actually have a t-shirt with a stop sign on it, and then you flash the car, it will stop. I proved that. But we can obviously, as we see these adversarial attacks, then we can train the cars to notice that it's actually a person wearing a t-shirt on it, so it's probably not a real stop sign. Before we introduce something into the fleet, we will run it in shadow mode, and we'll see what would this neural net, for example, have done in this particular situation. And then effectively, the drivers are training the net. So if the neural net would have controlled and say, veered right, but the person actually went left, and it's oh, there was a difference. Why was there that difference? It should be the car should be the less it knows, the slower it goes.
Yeah.
This is
not true at some point, but now it's
should be speed proportionate to confidence. In the short term, it's arguably we need all of the nets to be surround video, and so we still have some legacy. This is very short term. Obviously, we're fixing it fast, but there's still some nets that are not using surround video, and I think ideally that all use surround video. There's just a tremendous amount of work to do to make it work. You need talented people to join and solve the problem. There will be settings that you can say, are you typically a conservative driver, or do you want to drive fast or slow? I'm late for my I'm late for the airport. Could you go faster than, basically the kind of instructions you'd give to your Uber driver. It's, I'm late for the flight, please hurry, or take it easy, or whatever your style is. Yeah, I think that we should be worried about AI. Now, what we're trying to do here is, I'd say, a narrow AI, pretty narrow, like just make the car drive better than a human, and then have the humanoid robot be able to do basic stuff. At the point at which you start to get to superhuman intelligence, I don't know, all bets are off. But that'll probably happen. But what we're trying to do here at Tesla is make useful AI that people love and is unequivocally good. That's our try to aim for that. With Hardware 4, we will have a next generation camera. But I have to say that the current cameras, we have not reached the limit of the current cameras. And I'm confident we can achieve full self-driving with much higher safety than humans with the current cameras and current compute hardware. It would be good to be 1,000% better rather than 300% better. We'll see continued evolution on all levels in pursuit of that goal. And I think in the future, people will look back and say, wow, I can't believe we had to drive these cars ourselves. It'll like self-driving cars will just be just a normal, like self-driving elevators. Elevators used to have elevator operators, and there's someone there with a big relay switch operating the elevator, and then every now and then they'd get tired or make a mistake and shear somebody in half. So now we made the elevators automatic, and you just go and you press the button, and you can be in a 100-story skyscraper and don't really worry about it. Just go in and press a button, and the elevator takes you where you want to go. But it used to be that all elevators were operated manually. It'll be the same thing like for cars. All cars will be automatic, and electric, obviously. So there will still be some gasoline cars and some manual cars, just like there are still some horses. So should we bring up the bot? It's literally the first time the robot has operated without a tether was on stage tonight. So the robot can actually do a lot more than we just showed you. We just didn't want it to fall on its face. So we'll show you some videos now of the robot doing a bunch of other things, which are less risky. Yeah. What you saw was what we call Bumble C. That's our rough development robot using semi-off-the-shelf actuators. But we actually have gone a step further than that already. The team's done an incredible job. And we actually have an Optimus bot with fully Tesla-designed and built actuators, battery pack, control system, everything. It wasn't quite ready to walk, but I think it will walk in a few weeks. But we wanted to show you the robot, something that's actually fairly close to what will go into production and show you all the things it can do. So let's bring it out. So here you're seeing Optimus with the degrees of freedom that we expect to have in Optimus Production Unit 1, which is the ability to move all the fingers independently, to have the thumb have 2 degrees of freedom, so it has opposable thumbs and both left and right hand, so it's able to operate tools and do useful things. Our goal is to make a useful humanoid robot as quickly as possible, and we've also designed it using the same discipline that we use in designing the car, which is to design it for manufacturing such that it's possible to make the robot in high volume at low cost with high reliability. That's incredibly important. You've all seen very impressive humanoid robot demonstrations, and that's great, but what are they missing? They're missing a brain. They don't have the intelligence to navigate the world by themselves, and they're also very expensive and made in low volume. Whereas Optimus is designed to be an extremely capable robot, but made in very high volume, probably ultimately millions of units, and it is expected to cost much less than a car. I would say probably less than $20,000 would be my guess. The potential for is, I think, appreciated by very few people. As usual, Tesla demos are coming in hot. The team's put out an incredible amount of work. It's working 7 days a week, burning the 3 a.m. oil to get to the demonstration today. Super proud of what they've done. They've really done a great job. I'd just like to give a hand to the whole Optimus. Now there's still a lot of work to be done to refine Optimus and improve it. Obviously, this is just Optimus version 1, and that's really why we're holding this event, which is to convince some of the most talented people in the world, like you guys, to join Tesla and help make it a reality and bring it to fruition at scale such that it can help millions of people. And the potential, like I said, is really boggles the mind, because you have to say, what is an economy? An economy is sort of productive entities times their productivity, capita times output productivity per capita. At the point at which there is not a limitation on capita, it's not clear what an economy even means at that point. An economy becomes quasi-infinite. So what taken to fruition in the hopefully benign scenario, this means a future of abundance. a future where there is no poverty, where you can have whatever you want in terms of products and services. It really is a fundamental transformation of civilization as we know it. Obviously, we want to make sure that transformation is a positive one and safe, but that's also why I think Tesla as an entity doing this, being a single class of stock publicly traded, owned by the public, is very important and should not be overlooked. I think this is essential because then if the public doesn't like what Tesla's doing, the public can buy shares in Tesla and vote differently. This is a big deal. Like, it's very important that I can't just do what I want. Sometimes people think that, but it's not true. It's very important that the corporate entity that makes this happen is something that the public can properly influence. And so I think the Tesla structure is ideal for that. And like I said, the self-driving cars will certainly have a tremendous impact on the world. I think they will improve the productivity of transport by at least a half order of magnitude, perhaps an order of magnitude, perhaps more. Optimus, I think, has maybe a 2 order of magnitude potential improvement in economic output. Like, it's not clear what the limit actually even is. We need to do this in the right way. We need to do it carefully and safely and ensure that the outcome is one that is beneficial to civilization and one that humanity wants. This is extremely important, obviously. And I hope you will consider joining Tesla to achieve those goals. At Tesla, we really care about doing the right thing here, or aspire to do the right thing, and really not pave the road to hell with good intentions. And I think the road to hell is mostly paved with bad intentions, but every now and again there's a good intention in there. We really wanted to show the depth and breadth of Tesla in artificial intelligence, compute hardware, robotics, actuators, and try to really shift the perception of the company away from, a lot of people think we're like just a car company or we make cool cars, whatever, but most people have no idea that Tesla is arguably the leader in real-world AI hardware and software, and that we're building what is arguably the most radical computer architecture since the Cray-1 supercomputer. And I think if you're interested in developing some of the most advanced technology in the world that's going to really affect the world in a positive way, the place to be. Our goal with Optimus is to have a robot that is maximally useful as quickly as possible. So there's a lot of ways to solve the various problems of a humanoid robot, and we're probably not barking up the right tree on all the technical solutions. And I should say that we're open to evolving the technical solutions that you see here over time. They're not locked in stone, but we have to pick something. And we want to pick something that's going to allow us to produce the robot as quickly as possible and have it, like I said, be useful as quickly as possible. We're trying to follow the goal of fastest path to a useful robot that can be made at volume. And we're going to test the robot internally at Tesla in our factory and just see, like, how useful is it? Because you have to you've got to close the loop on reality to confirm that the robot is in fact useful. And so we're just going to use it to build things. And we're confident we can do that with the hand that we have currently designed. But I'm for sure there'll be hand version 2, version 3, and we may change the architecture quite significantly over time. I think we want to have really fun versions of Optimus, and so that Optimus can both be utilitarian and do tasks, but can also be like a friend and a buddy and hang out with you. And I'm sure people will think of all sorts of creative uses for this robot. And the thing, once you have the core intelligence and actuators figured out, then you can actually put all sorts of costumes on the robot. You can make the robot you can skin the robot in many different ways. And I'm sure people will find very interesting ways to versions of Optimus. Yeah, Optimus, we want over time for it to be an android, the kind of android that you'd seen in sci-fi movies, like Star Trek, The Next Generation, like Data. But obviously we could program the robot to be less robot-like and more friendly. And it can obviously learn to emulate humans and feel very natural. So as AI in general improves, we can add that to the robot, and it should be obviously able to do simple instructions or even intuit what it is that you want. So you could give it a high-level instruction, and then it can break that down into a series of actions and take those actions. Yeah, it is not strictly speaking, Optimus is not strictly directly in line with accelerating sustainable energy. To the degree that it is more efficient at getting things done than a person, it does help with sustainable energy. But I think the mission effectively does somewhat broaden with the advent of Optimus to, making the future awesome. I think you look at Optimus, and I don't know about you, but I'm excited to see what Optimus will become. And this is, you can tell, like any given technology, do you want to see what it's like in a year, 2 years, 3 years, 4 years, 5 years, 10? I'd say for sure. you definitely want to see what's happening with Optimus. Whereas a bunch of other technologies are plateaued. Don't name names here, but I think Optimus is going to be incredible in 5 years, 10 years, like mind-blowing. And I'm really interested to see that happen, and I hope you are too. Yeah, Optimus would definitely have conversational capabilities. You'd be able to talk to it and have a conversation, and it would feel quite natural. So from an end goal standpoint, I don't know, I think it's going to keep evolving, and I'm not sure where it ends up, but someplace interesting for sure. We always have to be careful about don't go down the Terminator path. I thought maybe we should start off with a video of the Terminator starting off with the skull crushing, but people might take that too seriously. We do want Optimus to be safe, so we are designing in where you can locally stop the robot, and with basically a localized control ROM that you can't update over the internet, which I think that's quite important, essential, frankly. Like a localized stop button or remote control, something like that cannot be changed. But it's definitely going to be interesting. It won't be boring. Dojo is a very big computer and actually will use a lot of power and needs a lot of cooling. So I think it's probably going to make more sense to have Dojo operate in like a Amazon Web Services manner than to try to sell it to someone else. So that would be the most efficient way to operate Dojo, is just have it be a service that you can use that's available online, and where you can train your models way faster and for less money. And as the world transitions to software 2.0,
and that's on the bingo card.
As someone I know has to know to drink 5 tequilas. Let's see. Software 2.0 will use a lot of neural net training. Makes sense that over time, as there's more neural net stuff, people will want to use the fastest, lowest cost neural net training system. So I think there's a lot of opportunity in that direction. We're already seeing robots that at least are able to generate very interesting art with like DALL-E and DALL-E 2. And I think we'll start seeing AI that can actually generate even movies that have coherence, like interesting movies and tell jokes. It's quite remarkable how fast AI is advancing at many companies besides Tesla. We're headed for a very interesting future. And I'm one of the QA testers. So I QA the car.
Yeah,
so I'm constantly in the car just QAing like whatever the latest alpha build is that doesn't totally crash. If it starts looking like we're going to be making a significant contribution to artificial general intelligence, then we'll for sure invest in safety. I'm a big believer in AI safety. I think there should be an AI regulatory authority at the government level, just as there is a regulatory authority for anything that affects public safety. So we have a regulatory authority for aircraft and cars and sort of food and drugs, and because they affect public safety, and AI also affects public safety. So I think, and this is not really something that government, I think, understands yet, but I think there should be a referee that is ensuring or trying to ensure public safety for AGI. And if you think of what are the elements that are necessary to create AGI, the accessible data set is extremely important. And if you've got a large number of cars and humanoid robots processing petabytes of video data and audio data from the real world, just like humans, that might be the biggest data set. It probably is the biggest data set, because in addition to that, you can obviously incrementally scan the internet. But what the internet can't quite do is have millions or hundreds of millions of cameras in the real world, and like I said, with audio and other sensors as well. So I think we probably will have the most amount of data and probably the most amount of training power. Therefore, probably we will make a contribution to AGI. Think about what drives any vehicle. It's a biological neural net with eyes, with cameras, essentially. And really, what is your primary sensor? Two cameras on a slow gimbal, a very slow gimbal. That's your head. If a biological neural net with 2 cameras on a slow gimbal can drive a semi-truck, then if you've got 8 cameras with continuous 360-degree vision, operating at a higher frame rate and much higher reaction rate, then I think it is obvious that you should be able to drive a semi or any vehicle much better than a human. I think from a technical standpoint, FSD beta should be possible to roll out FSD beta worldwide by the end of this year. For a lot of countries, we need regulatory approval, and so we are somewhat gated by the regulatory approval in other countries. But I think from a technical standpoint, it will be ready to go to a worldwide beta by the end of this year. And there's quite a big improvement that we're expecting to release next month that will be especially good at assessing the velocity of fast-moving cross-traffic, and a bunch of other things. And the version of FSD Beta that I drive actually does have the integrated stack. It uses the FSD stack both in city streets and highway, and it works quite well for me. But we need to validate it in all kinds of weather, like heavy rain, snow, dust, and just make sure it's working better than the production stack across a wide range of environments. But we're pretty close to that. I think it's, I don't know, maybe, it'll definitely be before the end of the year, and maybe November. Fundamental metric to optimize against is how many miles between a necessary intervention. Just massively improving how many miles the car can drive in full autonomy before an intervention is required that is safety critical. So that's the fundamental metric that we're measuring every week, and we're making radical improvements on that. I think there's some merit to just also like not being like necessarily too intense and like enjoying the moment a bit more. I would say to 20-something me, just to stop and smell the roses occasionally would probably be a good idea. It's like when we were developing the Falcon 1 rocket and on the Kwajalein Atoll, and we had this beautiful little island that we were developing the rocket on, and not once during that entire time did I even have a drink on the beach. I'm like, I should have had a drink on the beach. That would have been fine. It seems to me that AGI is advancing very quickly. Hardly a week goes by without some significant announcement. And yeah, at this point, like AI seems to be able to win at almost any rule-based game. It's able to create extremely impressive art, engage in conversations that are very sophisticated, write essays, and these just keep improving. And there's so many more talented people working on AI, and the hardware is getting better. I think it's on a strong exponential curve of improvement, independent of what we do at Tesla. And obviously, we'll benefit somewhat from that exponential curve of improvement with AI. Like Tesla just also happens to be very good at actuators, at motors, gearboxes, controllers, power electronics, batteries, sensors, and really, like I'd say the biggest difference between the robot on four wheels and the robot with arms and legs is getting the actuators right. It's an actuators and sensors problem, and obviously how you control those actuators and sensors, but it's actuators and sensors and how you control the actuators. I don't know, we have to have the ingredients necessary to create a compelling robot, and we're doing it. We're going to start Optimus with very simple tasks in the factory, like maybe just like loading a part, like you saw in the video, loading a part from one place to another, or loading a part into one of our more conventional robot cells that welds the body together. So we'll start just trying to, how do we make it useful at all? And then gradually expand the number of situations where it's useful. And I think that the number of situations where Optimus is useful will grow exponentially, like really fast. And in terms of when people can order one, I don't know, I think it's not that far away. I think you mean when can people receive one? So I don't know, I'd say probably within 3 years, not more than 5 years. Within 3 to 5 years, you could probably receive an Optimus. I think we have to be careful about Optimus being potentially used in ways that are bad, because that is one of the possible things to do. So I think we would provide Optimus where you can provide instructions to Optimus, but where those instructions are governed by some laws of robotics that you cannot overcome. Not doing harm to others, and you would have, I think, probably quite a few safety-related things with Optimus. It's interesting, on the bandwidth question, I think we probably will just end up increasing the bandwidth, which translates to the effective dexterity and reaction time of the robot. It's safe to say it's not 1 hertz, and maybe you don't need to go all the way to 100 hertz, but I don't know, maybe 10, 25, I don't know. But over time, I think the bandwidth will increase quite a bit, or translated to dexterity and latency. You'd want to minimize that over time, minimize latency, maximize dexterity. In terms of breadth and depth, we're a pretty big company at this point, so we've got a lot of different areas of expertise that we necessarily had to develop in order to make in order to make electric cars, and then in order to make autonomous electric cars. Tesla is like a whole series of startups, basically, and so far, they've almost all been quite successful. So we must be doing something right. And I consider one of my core responsibilities in running the company is to have an environment where great engineers can flourish. And I think in a lot of companies, I don't know, maybe most companies, if somebody's a really talented, driven engineer, they're unable to their talents are suppressed at a lot of companies. And some of the companies, the engineering talent is suppressed in a way that is maybe not obviously bad, but where it's just so comfortable and you're paid so much money, but the output you actually have to produce is so low that it's like a honey trap. So there's a few honey trap places in Silicon Valley, but they're not necessarily don't seem like bad places for engineers, but you have to say a good engineer went in, and what did they get out? And the output of that engineering talent seems very low, even though they seem to be enjoying themselves. That's why I call it, there's a few honey trap companies in Silicon Valley. Tesla is not a honey trap. We're demanding, and You're going to get a lot of shit done, and it's going to be really cool, and it's not going to be easy. But if you are a super talented engineer, your talents will be used, I think, to a greater degree than anywhere else. SpaceX also that way. We're not actually specifically focused on AGI. I'm simply saying that AGI seems likely to be an emergent property of what we're doing, because we're creating all these autonomous cars and autonomous humanoids that are actually with a truly gigantic data stream that's coming in and being processed. It's by far the most amount of real-world data, and data you can't get by just searching the internet, because you have to be out there in the world and interacting with people and interacting with the roads, and Earth is a big place, and reality is messy and complicated. So I think it just seems likely to be an emergent property of if you've got tens or hundreds of millions of autonomous vehicles and maybe even a comparable number of humanoids, maybe more than that on the humanoid front. That's just the most amount of data. And if that video is being processed, it just seems likely that the cars will definitely get way better than human drivers, and the humanoid robots will become increasingly indistinguishable from humans, perhaps. Then, like I said, you have this emergent property of AGI. And arguably, the humans collectively are a superintelligence as well, especially as we improve the data rate between humans. The thing that seemed to me way back in the early days of the internet was like humanity acquiring a nervous system, where now all of a sudden any one element of humanity could know all of the knowledge of humans by connecting to the internet, almost all the knowledge, or certainly a huge part of it, whereas previously we would exchange information by osmosis. We'd have to, in order to transfer data, so you would have to write a letter. Someone would have to carry the letter by person to another person, and then a whole bunch of things in between. And then it was insanely slow when you think about it. And even if you were in the Library of Congress, you still didn't have access to all the world's information. And you certainly couldn't search it. And obviously, very few people are in the Library of Congress. The great quality elements. Like the internet has been the biggest equalizer in history in terms of access to information and knowledge. And any student of history, I think, would agree with this, because if you go back 1,000 years, there were very few books, and books would be incredibly expensive, and only a few people knew how to read, and only an even smaller number of people even had a book. Now, look at it, like you can access any book instantly. You can learn anything basically for free. It's pretty incredible. I was asked recently, what period of history would I prefer to be at the most? And my answer was right now. This is the most interesting time in history, and I read a lot of history. So let's do our best to keep that going. Yeah. And to go back to one of the earlier questions I would ask, the thing that's happened over time with respect to Tesla Autopilot is that the neural nets have gradually absorbed more and more software. And in the limit, of course, you could simply take the videos as seen by the car and compare those to the steering inputs from the steering wheel and pedals, which are very simple inputs. And in principle, you could train with nothing in between, because that's what humans are doing with a biological neural net. You could train based on video, and what trains the video is the moving of the steering wheel and the pedals, with no other software in between. We're not there yet, but it's gradually going in that direction. The number one design requirement at Tesla is safety, and that goes across the board. So in terms of the mechanical safety of the car, we have the lowest probability of injury of any cars ever tested by the government for just a passive mechanical safety, essentially crash structure and airbags and whatnot. We have the highest rating for active safety as well. And I think it's going to get to the point where the active safety is so ridiculously good, it's just absurdly better than a human. And then with respect to autopilot, we do publish broadly speaking, the statistics on miles driven with cars that have no autonomy, or Tesla cars with no autonomy, with kind of hardware 1, hardware 2, hardware 3, and then the ones that are in FSD beta. And we see steady improvements all along the way. And sometimes there's this dichotomy of, should you wait until the car is, 3 times safer than a person before deploying any technology? But I think that is actually morally wrong. At the point at which you believe that adding autonomy reduces injury and death, I think you have a moral obligation to deploy it, even though you're going to get sued and blamed by a lot of people, because the people whose lives you saved don't know that their lives are saved. And the people who do occasionally die or get injured, they definitely know, or their estate does, that there was a problem with autopilot. That's why you have to look at the numbers in sort of total miles driven, how many accidents occurred, how many accidents were serious, how many fatalities. And we've got well over 3 million cars on the road, so that's a lot of miles driven every day. And it's not going to be perfect. What matters is that it is very clearly safer than not deploying it. I think it would be cool to have make Inspector Gadget real. That would be pretty sweet. So yeah, right now we just want to make a basic humanoid work well, and our goal is fastest path to a useful robot. I think this will ground us in reality, literally, and ensure that we are doing something useful. Like one of the hardest things to do is to be useful, to actually, and then to have high utility under the curve of like how many people did you help and how much help did you provide to each person on average, and then how many people did you help? The total utility, like trying to actually ship useful product that people like to a large number of people is so insanely hard. It boggles the mind. That's why I can say, man, there's a hell of a difference between a company that has shipped product and one that has not shipped product. This is night and day. And then even once you ship product, can you make the value of the output worth more than the input? Which is, again, insanely difficult, especially with hardware. But I think over time, it would be cool to do creative things and have 8 arms and whatever, and have different versions, and maybe there'll be some hardware, like companies that are able to add things to an Optimus, like maybe we add a power port or something like that, or attachment. You can add attachments to your Optimus, like you can add them to your phone. There could be a lot of cool things that could be done over time, and there could be maybe an ecosystem of small companies or big companies that make add-ons for Optimus.